So for a kite, yeah. So think back to parallelograms. What made a parallelogram that's in the name that makes it a parallelogram?
The opposite sides are parallel.
All the opposite sets of sides are parallel. Kites are exactly opposite that. So kites have 0 parallel sides. None. So what makes it a kite then?
It looks like a flying kite.
It looks like a kite.
Yeah.
Feel free to, like draw the little tail on the bottom, put little bows on it or something, I don't know. But it's a, so what makes a kite be a kite? Okay, well what it is it's actually made of 2 special triangles stuck together.
Oh.
Yes, but I just highlighted 2 of them. I just highlighted this orange one and this blue one. What do you notice, based on what I've marked, is special about those 2 triangles? They are both isosceles. Are they the same size of isosceles triangle? No, but they are both isosceles. So I have 2 sides congruent, and I have 2 other sides congruent. And that's what makes it a kite. Now, are these the opposite sides from each other, like they were in a parallelogram? No, look, this side across from this one, those are not the same size. And these ones are not the same size. So how are we going to say that the sides that aren't opposite are congruent? Adjacent, we've got one that we were using, because adjacent sounds like adjacent angles, and that's not what we have. How about we go with consecutive? Remember that one? Which kind of means the things that come right next to each other. Okay, so a kite is a quadrilateral. Oh, do you want to just write the implied statement? Yeah. Let's just do the implied. So a kite implies that you have a quadrilateral. You have to say that it's 4-sided. Otherwise, everything else could be something different. So it's a quadrilateral with 2 pairs of consecutive sides congruent. Because basically the stuff from one triangle is congruent and the stuff for the other triangle is congruent. And so a fancy thing to note about kites is that one of the diagonals cuts the kite into, what shapes? What kind of triangles? It's 2 isosceles triangles. So that's what's special about kites. Because if it was, like a rectangle, they aren't necessarily going to be isosceles. But with a kite, it's always this one is and this one is. Okay? Wait a second. Hold on. So we got here a kite, right? Yeah. So in a kite, there's this diagonal that cuts it into the isosceles triangles. What if I drew that diagonal in my kite? Are those isosceles triangles? No, because these 2 were congruent and these 2 were congruent, but is that isosceles right there? No. And is that isosceles right there? No. So only one of the diagonals makes isosceles triangles. Okay? But what's my reflexive property, tell me?
Share lines.
You're congruent to yourself?
Yeah.
The other diagonal don't write this down, makes congruent triangles. I'm going to tell you where to write it. You want to know where to write it? If it makes congruent triangles, what do congruent triangles imply? Congruent parts. So like this part's congruent to this part's congruent to this part. How would you describe these congruent angles? Where are their positions in the kite? They're what? Well, that's a triangle, but how would you describe those angles by their position? They're the opposite angles. So, that's one of your implied statements about a kite. In a kite, you have exactly one pair of opposite angles being congruent. Okay. And now I can erase this garbage. And are these two angles where the congruent sides meet? Are these guys congruent to each other? No. So where the congruent sides meet, those angles aren't congruent. But where the different sides meet, the angles are congruent. And so this special set of congruent angles is where the non-congruent sides meet. So the sides that aren't congruent meet in an angle that is. You're like, okay, that's fine. I can handle that. That's not so bad. In mine, I'm going to erase this diagonal just because it bugs me. You don't have to in yours. So, oh behold, I'm telling you, another kite. Let's do another implied statement. And what did I know about this diagonal of the kite? Well, that side was congruent, right?
Oh, yeah.
And those two were congruent, right?
Oh, yeah.
And these ones were congruent?
Yes, ma'am.
So what kind of triangles were they? Scalene. And what is true about those two things? The two triangles?
They're congruent.
What are they congruent by? Side, side, side. So I've got congruent triangles by side, side, side. Well, aren't corresponding parts congruent?
Yeah.
Oh, look. That's a set of congruent angles that are adjacent. What do congruent adjacent angles imply?
Angle bisector.
An angle bisector. But wait, there's more.
There's always more.
How many angles in a triangle are there?
3.
So wouldn't these also be congruent?
And then the other one will be due.
And so that one's bisected as well? What object is doing the bisecting?
That segment.
This segment, what's this segment called? That's a diagonal. Okay, so I've got to take it off of here and come put it on this one now so that everybody at home can see it. So since these triangles are congruent, you have that these angles are congruent, these angles are congruent, which means the diagonal bisects opposite angles. Exactly one diagonal bisects opposite angles. So the angles, these are the angles that didn't match up, right? These angles didn't match up, but they get to be bisected. The angles that are congruent, do they get to be bisected? Nope. So this set of angles is congruent to this set of angles, but if I draw that line there, right through it, okay, this part on top is not the same as the angle on bottom. Okay? And so you have to figure out how to keep straight which angles match, which angles don't match, and which angles get bisected. Huh? A lot of repetition will help with that. And a lot of staring at it too. Okay? What else do y'all notice about the kite? What seems to be true here?
So many triangles.
There are a lot of triangles. There's 1, 2, 3, 4, 5, 6, 7, 8 that I spot.
Yeah.
There's many I spot.
Indeed, they're really.
Well, maybe focus in on those diagonals.
They make
Is that
90-degree angle.
Oh, and what's it called when lines make 90-degree angles? The diagonals are perpendicular. So that's your implied statement for this one. A kite implies perpendicular diagonals. Wait a minute, where have we heard that before? Rhombuses had perpendicular diagonals. That's why it can't be biconditional.
We do squares.
Well, squares are a type of rhombus, right?
Oh, yeah.
Yeah. And so if you have perpendicular diagonals and that's all you know, can you say for sure if it's a rhombus or a kite? No. That's why these can't be biconditional, because perpendicular diagonals is not specific enough. Okay? Wait a minute. Hold on. One other thing. If this triangle on the right is congruent to this triangle on the left, so that these angles are congruent, all the parts are congruent, is an altitude considered a part of a triangle? Yeah. So this is the altitude of the right-hand triangle since it's perpendicular. And this is the altitude of the left-hand triangle because it's perpendicular. So what's true about those altitudes? They are congruent. But wait, those altitudes together make what part of the kite?
The middle.
What's this piece that goes from up? That's a diagonal. So one of the diagonals is bisected by the other. Do they both get bisected?
No.
Well, what happened if both diagonals bisected each other? It'd be a parallelogram, because that's one of your parallelogram properties, is that both diagonals bisect each other. So only one of them bisects. The one that gets bisected is the one that's between your two different isosceles. You've got this isosceles on top, this isosceles on bottom. This diagonal between is the one that gets bisected. Okay? So you're like, wow, kites are a lot more complicated than I thought, huh? What shape does this make right here? What kind of triangle? Which can be solved using Pythagorean theorem, or special rights, or trigonometry. So much fun to be had with kites. So let's not do all the problems, but let's make sure we know how to set them up. So on this fella here, how would I find x? There's x, I found it.
Pythagorean theorem.
How do I know I can do Pythagorean theorem?
We have two sides. You can.
Because the diagonals must be perpendicular. And that makes a right triangle right there. So how big is it going to be, those of you who know your Pythagorean triple? 6, 8? 10.
What?
If you do Pythagorean theorem, it works too, but some people know the triple. Okay, but wait, how about y?
That's angle.
It's this whole angle here. Yep.
2y plus 36 equals 7.
How do you know it equals 76?
Because they're the opposite. It
The-
could be one diagonal.
The one set of opposite angles is congruent, and it's the set between the two sides that aren't. So I know these are congruent, so 2y would have to equal what, 40? And y would be 20? Okay? This is why you need to be so familiar with your properties. Is because the algebra is not hard, but if you have to spend 5 minutes on each problem just figuring out what to do, you're going to run out of time. All right, now look at this figure. It's a kite. See, its little tail and everything. It's so cute. Okay? Now it says AB has to equal 5, AE has to equal 4, and EC has to equal 12, and they want you to find BC. thoughts on how we could accomplish this?
Pythagorean,
How come?
because 4, 5.
Is it right angles?
Because the diagonals make right angles.
No.
So I've got 4 and 5 here. Oh, who knows the triple with 4 and 5? Yeah, that's going to be 3, 4, 5, but that's not what I wanted. That's not
Well, then you
BC.
can do the Pythagorean theorem on the other one.
Then I could do Pythagorean theorem here. That one doesn't come out as pretty. That one comes out to be something like 3 root 17 or something disgusting like that. But, you know, it gets the idea across. So, oh look, you get to keep doing Pythagorean. I wonder why we've been doing that in our warm-up so much.
That's crazy, man.
I know, it's almost like we planned it.
It's like,
Okay, that's enough kites.
No more
Shh. So parallelograms had 2 sets of sides parallel. Kites have no sides parallel. Guess what trapezoids do?
got 1 second.
Just 1 set of parallel sides. So your trapezoid, it's a trap, implies that you have a quadrilateral, you've always got to say it's a quadrilateral, with exactly 1 pair of opposite, I can spell, sides that are parallel. Only 1 set. Look, there they are. Yep. We got to give those fancy names. What should we call those?
Call what?
The parallel sides.
Oh, yeah.
Well, did you know that a trapezoid is really just a triangle that's been beheaded? See?
guillotine.
If you just connected those up there, that would be a triangle, right?
Yep.
And you just cut off the top of it parallel to this part, the base of the triangle. So what should we call it? We'll call this the base, but since we cut this one off parallel, it also gets to be a base. Does the long base always have to be on bottom?
No.
No. You see something like this and you're like, oh wait, is that a trapezoid? Yeah. It looks like it's standing on its head, but yeah, that's a trapezoid. Can they be on their side? Yeah. Could you draw one like this?
What are you doing?
Yeah. Does that make you slightly uncomfortable
No.
for some reason?
No.
Some people, it bothers them if it's not flat on the bottom.
Yeah.
Yeah, whatever.
It looks like,
Oh, what should we, oh wait, so if 2 of the sides are parallel, what has to be true about the other 2? They are not parallel. These guys can never be parallel. Shh, because if both sets of sides were parallel, what would you have? A parallelogram. And so they can't be, so they can't be called bases, so what should we call them?
side.
What did we call them? What did we call the sides of triangles that weren't the base? Legs. So we just call them legs.
Like not bottom side.
I know, but that was what we did for triangles, so that's what we're doing here. Do your legs have to be congruent?
No.
No. You can have one leg like this and the other leg really long and go all the way out to there.
Yeah, way to go.
Okay? That is technically a trapezoid. It does. I'm an artist. Okay? So the legs don't have to be congruent, but, and it's a pretty big but, what if they were?
An isosceles trapezoid.
We call that an isosceles trapezoid. And so in an isosceles trapezoid, you've got your 2 legs being congruent. So isosceles trap implies congruent legs. Can the bases ever be congruent? No, because if the bases, well, because remember, if the bases were congruent, then you had a set of sides that's both parallel and congruent. And what does that imply? Parallelogram. So Only the legs get to be congruent, never the bases. Okay? Wait a second. I have parallel lines. What's that going to tell me about these same side interior angles? Supplementary. So your same side interior angles are supplementary. So that's just one of our old parallel properties, right?
Yeah.
It just happens to show up inside a trapezoid. What about on the other side?
Same thing.
Same thing's going to happen.
Okay.
But wait, this is an isosceles trapezoid.
Okay.
And in an isosceles trapezoid, guess what else? Guess what's congruent? Those base angles. But wait, isn't this a base? So its base angles are also congruent. So in an isosceles trapezoid, that's going to imply that you've got base angles congruent. And that's going to be two sets of them. Both sets will do that in an isosceles trapezoid. I know, your mind is blown.
Wow.
So amazing. Everything you could have ever dreamed. But wait,
There's one.
draw the diagonals in this last guy. Diagonals, remember that goes to non-consecutive vertices?
Right triangle.
Oh, no, no bright triangles here.
You messed up my angle.
Okay, what shape are we doing again? This is isosceles, so these are congruent. Wait a second. You guys did this back in our congruent triangles unit. Watch. Remember that the base angles have to be congruent? And so this triangle and this triangle share a side. And so what's true about the triangles? They're congruent by side angle side. Which means, stop, what's true about congruent triangles? All their parts are congruent, including these, which are diagonals. So, in an isosceles trapezoid, the diagonals must be congruent. You proved these were congruent back in our triangles unit. I just left this leg off. And you just proved this. But you were really proving that the diagonals of an isosceles trapezoid are congruent. You did that for us months ago. Months ago. I know, you're excited. You are all being recorded.
Yeah, you're
So, without doing all the work, let's just look at this fellow real quick. It says snit is an isosceles trapezoid with bases NS and IT. Where should we put the letters?
in order.
Well, one of my bases is NS.
Bottom right and then to the left.
Okay, well, how about we do it by the bases? One of the bases is NS. The other base is IT. Have I done it in the order that it says snit?
Yes.
Are there other ways you could have arranged it where it would still say snit and have the bases be those? Yes, it's okay as long as you meet the rules. If it goes around and says snit and NS and IT are the bases, you're fine. Okay? And it says R, where's R? R is going to be where the diagonals intersect. So it says the measure of, no, we're not going to do that. The measure of angle RTI here is 24. The measure of angle NST, this big fella here, is going to be 133. Okay? How am I going to figure out IRT if it's an isosceles trapezoid?
Marcy? I don't know.
Well, wait a minute. Aren't my consecutive angles supplementary?
Oh my God.
And so if this one's 133, how big does this whole guy have to be? 47. And so if this was 24, how big is this guy? This is 23. Okay? And so now I've got that is that much. And oh wait! In an isosceles trapezoid, what's true about the base angles? They're the same. So this guy's 47. Okay. So let's see. So this will be 24, and this will be 23 because of those congruent triangles. So how big is this angle in the middle going to be? And how will you get that?
180.
Yeah, you have a triangle that adds to 180, so take away the 48, and you get 132. Okay? So that's the kind of thing you're going to be doing on your homework tonight. We're not going to do all of them, okay? Because we don't have time. But that's the kind of stuff you're going to do. Turn the page. One more thing.
Oh, Jesus.
Remember, trapezoids are just triangles whose heads were cut off parallel to the base. And in triangles, we had a lovely little thing called a mid-segment. Candy to whoever can raise their hand and tell me what a mid-segment did. Raise your hand. Yes.
It's in the middle.
Nope, that's not specific enough.
You ain't wrong.
Yes?
Midpoint?
No, I want a mid-segment, not a midpoint.
Oh, no.
A midpoint is a midpoint. I need something that's a mid-segment. Its name tells you. Yes?
It cuts the segment into two congruent?
No.
It cuts a shape.
Nope. A mid-segment
Segment
is it's a segment that connects the midpoints. Oh! But what do midpoints imply?
Two
Collinear. So this is congruent to this, and that one's congruent there.
That's great.
Wait, hold on. We did this back in our triangles unit. What was the special thing that happened when you did a mid-segment in a triangle?
Like in half, I think.
Well, it cut those in half, but what else magic did it do? It was parallel to the base. But this one has two bases. So it's parallel to both. So it connects midpoints of the legs and is parallel to the bases. Okay. Now, are our bases ever the same size?
No.
No. So one of them is going to be shorter, one of them is going to be longer, and if the mid-segment's in the middle, how could you figure out how long it is?
I had to get it divide half.
What's that called in math words? Averaging. To get the length of your mid-segment, what we're going to do is we're going to add your bases. Let's call this one base 1 and this one base 2, because if you call them the same name, you're saying they're the same size. So we get it by adding up base 1 plus base 2, and then what do? Divide by 2, and that'll give you the length of the guy down the middle. Oh! Boy, I bet we can have all sorts of fun with that in a problem, especially because, oh look, if it's parallel, what's going to be true about these same side interior angles?
Supplementary.
But what's going to be true about these corresponding angles?
They're
Congruent. What about these corresponding angles?
they're congruent.
They're congruent. What about these corresponding angles? Oh, but what about these same side interior angles?
Supplementary.
Wow, I bet we can have a lot of fun with that, huh?
Pretty much.
Okay, so I'll let you have fun with that on the homework. Let's do this chart real quick. Shh. So here are all of the quadrilaterals we've discussed. Which ones can you check off that have all sides congruent?
Square.
All the rhombuses, which includes the squares. Okay. Which ones have both pairs of opposite sides congruent? Parallelograms,
Rectangle.
which includes rectangles
Rhombus.
and rhombuses
Square.
and squares. What about both pairs of opposite sides being parallel?
Parallelogram.
Parallelograms, which include
Rectangle.
rhombus and squares. Okay? Which ones have exactly one pair of opposite sides parallel?
Right and trapezoid.
That's your trapezoids. Kites don't get any, do they? Poor kites. Ooh. What about all the angles are congruent? Kites have all the angles congruent? No. It's just going to be rectangles, but what's a special rectangle? The square. Exactly one set of opposite angles congruent. That's your kite. Okay, because if it had both sets of opposite angles, you're going to have that parallelogram. Where are the diagonals perpendicular? Rhombuses, and that includes squares, and our kites. Where are our diagonals congruent? The rectangles, which includes squares.
What about a parallelogram?
Does every parallelogram have congruent diagonals? No, it's just the ones with right angles.
And then trapezoid.
Are all the trapezoids going to do it?
Oh, no.
How about we just say only the isosceles trapezoids will have congruent diagonals? Okay. Which ones have diagonals bisecting, both diagonals bisecting each other? All the parallelograms, which includes rectangles, rhombuses, and... What about the kites?
No. They only have one.
They only have one diagonal that bisects the other. So you don't want to put kites there because this is including all of them. Okay? So thank you for being tolerant.